All right, ICP people, this is Mr. Simmons, and these are our notes over 1.2 standards of measurement. Let's fix that real quick. All right, these should be used in conjunction with the 1.2 standards of notes outline, and it's worth 10 points, and it's due next week when I tell you. All right, in this section, 1.2, we're going to learn how to measure things and learn about the measurement standards. All right, here we go. Vocab for this section, we have standard, SI, volume, mass, and density. Measurement systems. Suppose you and a friend want to make some measurements to find out whether a desk will fit through a doorway. You have no rulers, so you decide to use your hands as measuring tools. Even though you both use hands to measure, you didn't check to see whether your hands were the same width as your friend's. In other words, you didn't use a measurement standard, so you can't compare the measurements. Your hands are different widths, and you weren't using the same standard. Hands are a convenient measuring tool, but using them can lead to misunderstanding. So a standard is an exact quantity that people agree to use to compare measurements. Suppose the label on a ball of string indicates the length of the string is 150. No units. Is the length 150 feet, 150 meters, or 150 centimeters? All these are very different lengths, and they're all based on the unit behind it. For a measurement to make sense, it must include a number and a unit. International System of Units. So, all SI standards are universally accepted and understood by the scientists throughout the community. It's International System of Standards, and SI for Sistemes Internationales, something like that. So, used to measure length, volume, mass, density, and temperature. So, quantity measured, length, we'd measure in meters, and the symbol is M. Volume, we measure in liters, the symbol is L. Mass, we measure in grams, and the symbol is G. Density is grams per milliliter, and so that's gram over milliliter. And temperature is in Celsius, and the symbol is C. Metric prefixes. Prefixes to either multiply or divide by some amount of 10. It has a base unit plus a prefix. So prefixes to memorize. We'll work on this in class and probably have a separate video. But prefixes that multiply, if you see deca or dk in front of meter, liter, gram, it means 10 meters. So a decameter is 10 meters. 1 decameter equals 10 meters. A hecto is, you multiply by 100. So 1 hectometer is 100 meters. In kilometer or kilometers, you've probably heard of this, not so much the other two, multiplies by what? We have 10, we have 100. What do you think the next unit is? We're just adding zeros. And it'd be 1,000. So a kilometer or kilometer is 1,000 meters lined up. More prefixes to memorize. Prefixes that divide, deci with a D, so a decimeter is 1/10 of a meter. I'm sure you've heard of centimeters. So a centimeter is 1/100th. See, we just added a zero. We're dividing. We're getting smaller. And a millimeter is 1/1000th of a meter. So it takes 1,000 millimeters to make 1 meter. These can also be used with liter or gram. Decigram, centigram, milligram, 1,000. They all mean the same. Meter, liter, or gram tell you what you're measuring as far as length, volume, or mass. And we have the prefixes that tell you how much of it we have. So a convenient way to memorize this is kids have dropped over Dead, converting, ing should be right here. Metrics. Kilo, hecto, deca, base unit is O. And we just say it's O to fit this little mnemonic device. D, dead is deci, centi, and milli. So we have kilo, hecto, deca, base unit, deci, centi, and milli. And we'll learn how to convert these later on. So if you want to convert kilometers to meters, you're going to move the decimal place 3 places to the right. And I'll show you how to do this in a later video. If you want to convert millimeters to centimeters, you're going to move 1 to the left. Here's some practice problems. So 1,000 milligrams. 1,000 milligrams, we want to convert it to hectograms. So we're going to practice this. So we're going from milli to hecto. We're measuring mass here because we have grams. So we have 1,000 and we want to go to H, M to H. So let's look back at our kids have dropped over dead converting metrics. We're going M and we're going all the way over to H. So we're going to count 1, 2, 3, 4, 5 to the left. So we're moving to the left, so we're going to go back to our problem. And the decimal point would be right here. We're going to go 5 to the left. 1, 2, 3, 4, 5. So our answer ends up being 0.01 hectometers. If we want to convert 160 centimeters to millimeters, it's still the same amount because it's equal. We're just using different prefixes. We're measuring length because we have meters. So let's go back and look at our kids have dropped over dead converting metrics. Centa to milla. So we're going C to M. Kids have dropped over dead converting metrics. C to M. So we're going 1 to the right. So we're getting bigger. The number's getting bigger because the units get smaller. So we go back to our problem. We go 1 to the right. Right here's the decimal point. So we go 1 to the right. And so 160 centimeters equals 1,600 millimeters. They're the same measurement. They're just 1/10 off. So hence the extra 0 here. 1 kiloliter, we're going from kiloliter to milliliter, so we're measuring volume with liter, and we're going from kilo to milli, and so let's look at our kids have dropped over dead converting metrics. So we go 1, 2, 3, 4, 5, 6 to the right, using this little device. We go back to our problem, so we're going to go 1, 2, 3, 4, 5, 6 to the right. We're going to add 6 zeros, and so right here we started at 1. So we go 1, 2, 3, 4, 5, 6. So 1 kiloliter is 1 million milliliters. And let's do one more. Here we have 250 decimeters, and we're going to convert that to decameters. So let's go back up. Deci to deca. So we're right here is decimeters. We're converting to decameters. So we go 1 to the left. So look at the problem here. If we have 250, what do you think the answer would be? We'll go to the left. So 1, 2. So we should see 2.5 decameters. They're still equal to each other, but the numbers are different because the units in front are different, the prefixes. So length is the basic unit of length in the metric system is meters. So if you see kilometer, decimeter, centimeter, we're measuring the length of something. Volume, the amount of space occupied by an object. The units, there's a couple different units. If you use length, centimeters cubed, meters cubed, but normally we use liters. Mass is how much matter an object has, the type and number of atoms. So we're going to use mainly grams and kilograms, sometimes milligrams. So all these grams is the measurement for mass. Density is the mass per unit of volume of a material. And so the mass divided by volume, we're going to have grams over milliliters. Write that down, grams over milliliters. Temperature is measured in degrees Celsius. You guys can't see that. And the font is a little bit off for some reason. but temperature is measured in degrees Celsius, and it's based on the boiling and freezing point of water. And so water freezes at 0 degrees Celsius, and it boils at 100 degrees Celsius. We're used to Fahrenheit. There also is Kelvin, but in science they mainly use Celsius, based on the freezing point and the boiling point of water. So let's review. Question 1. A blank is an exact quantity that people agree to compare measurements. What do you think that would be? Variable, standard, unit, or control? It's going to be standard. SI standards are universally accepted by scientists around the world and understood by scientists throughout the world. You read it. Question 2. A kilogram is equal to how many grams? So we're going from kilogram to gram. If you look back at our kids have dropped over dead converting metrics. Maybe I should have done this, but we'll keep going. Kids have dropped over. So right here's our gram. That's gram, meter, or liter. So we're going 1, 2, 3 to the right. So we're going to take our decimal point. Three to the right. So we go back to our answer here. 1 kilogram. So we're going to go 3 to the right. So is it 1,000, 110, or 1? We had 1. So we're going to go 1, 2, 3. We're going to add 3 zeros. So the correct answer should be A. I swear I fixed all these before the video. Maybe I didn't. The answer is A. The prefix kilo means 1,000. So in a kilogram, we're going to have 1,000 grams. Question 3. The amount of space occupied in an object is called what? It is volume. To find the volume of a solid rectangle, measure the length by its width and its height. And that's why we often use centimeters cubed or meters cubed, because we have 3 different lengths multiplying. And those are your standards of measurement notes. Have a great day. Thank you.